Good day everyone, I'm Mark Jason New Season, and for this day we will discuss regression testing in JUnit. My first topic is regression testing, but first, let's discuss what is testing. Testing is the process of checking the functionality of an application to ensure it runs as per requirement. Unit testing comes into picture at the developer's level. It is the testing of a single entity, either class or method. Unit testing plays a critical role in helping a software company deliver quality products to its customer. Unit testing can be done in two ways, either manual testing or automated testing. As shown in the image, we can see the difference between manual testing and automated testing. Regression testing is a black box technique. It is used to authenticate the code. Change in the software does not impact the existing functionality of the product. Regression testing is making sure that the product works fine with the new functionality, bug fixes, or any change in the existing feature. Regression testing is a type of software testing. Test cases are executed to check the previous functionality of the application is working fine and the new changes have not produced any bugs. Regression testing can be performed on a new build when there is a significant change in the original functionality. It ensures that the code still works even when the changes are occurring. Regression testing means retest those parts of the application which are unchanged. Regression tests are also known for verification method. These test cases are often automated. Test cases are required to execute many times and running the same test case again and again manually. It is time consuming and tedious too. Regression testing does not depend on any programming languages. Here we are going to take a case to define the regression testing efficiently. Consider a product Y in which one of the functionality is to trigger a confirmation, acceptance, and dispatch email. It also needs to be tested to ensure that the changes in the code does not affect them. As I said earlier, regression testing does not depend on any programming languages like Java, C++, C Sharp, etc. This method is used to test the product for modifications or any update done. It ensures that the changes in the product does not affect the existing module of the product. Verify that the bug fixes and the newly added feature not created any problem in the previous working version of the software. When can we perform regression testing? We do regression testing whenever the production code is modified. We can perform regression testing in the following scenario. First, when the new functionality added to the application. Example, a website has a login functionality which allow user to log in only with email. Now, providing a new feature to do login using Facebook. Number 2, when there is a change requirement. Example of this is remember password from the login page which is applicable previously. Third, when the defect speaks. Example, assume login button is not working in a login page and a tester report a bug stating that the login button is broken. Once the bug fixed by the developers, tester tests it to make sure login button is working as per expected. Simultaneously, tester tests other functionality which is related to the login button. Number 4, when there is a performance issue fix. Example of this is a loading page takes 5 seconds, reducing the load time to 2 seconds. Number 5, when there's an environment change. Example of this is when we update the database from MySQL to Oracle. How to perform regression testing. The need for regression testing comes when the software maintenance include enhancement, error corrections, optimization, and the deletion of existing features. This modification may affect system functionality. Regression testing becomes necessary in this case. Regression testing can be performed using the following techniques: retest all, regression test selection, and the third, prioritization of test cases. First, let's discuss retest all. Retest is one of the approaches to do regression testing. In this approach, all the test case suits should be re-executed. Here, we can define retest as when a test fails and we determine the cause of the failure is a software fault. The fault is reported. We can expect a new version of the software in which defect is fixed. In this case, we will need to execute the test again to confirm that the fault is fixed. This is known as retesting. Some will refer to this as confirmation testing. The retest is very expensive as it requires enormous time and resources. Second one is regression test selection. In these techniques, a selected test case suit will be executed rather than an entire test case suit. The selected test case suits divided into two cases: reusable test cases and absolute test cases. Reusable test cases can use in succeeding regression cycle, while the obsolete test cases can use in succeeding regression cycle. The third one is prioritization of test cases. It's prioritize the test case depending on business impact, critical, and functionality use. Selection of test cases will reduce the regression test suite. The regression testing process can be performed across the builds and the releases. Let's discuss regression testing across the builds. Whenever the bug speaks, we retest the bug, and if there's any dependent module, we go for a regression testing. For example, how we perform the regression testing if we have different builds, like build 1, build 2, and build 3, which having different scenarios. For the build 1, firstly, the client will provide the business needs. Then the development team start developing the features. After that, the testing team will start writing the test cases. For example, they write 900 test cases for the release number 1 of the product. And then they will start implementing the test cases. Once the product is released, the customer perform one round of acceptance testing, and in the end, the product is moved to the production server. And for the build number 2, now the customer asks for extra 3 to 4 features to be added, and also it provides the requirement for the new features. The development team start developing a new features. After that, the testing team will start writing the test case for the new features, and they write about 150 new test cases. Therefore, the total number of the test case written is 1050 for both the releases. Now the testing team start testing the new feature using 150 new test cases. Once it is done, they will begin testing the old features with the help of the 900 test cases to verify that adding the new features has never damaged the old features. Here, testing the old feature is known as regression testing. Once all the features, the old and the new, have been tested, the product is handed over to the customer, and then the customer will do the acceptance testing. Once the acceptance testing is done, the product is moved again to the production server. For build number 3, after the second release of the software, the customer want to remove one of the features like sales. Then he or she will delete all the test case which are belonging to the sales module, about 120 test cases, and then test the other feature for verifying that if all the other features are working fine after removing the sales module test cases, and this process is done under the regression testing. Now let's discuss the regression testing across the release. The regression testing process starts whenever there is a new release for the same project, because the new feature may affect the old element in the previous releases. To understand the regression testing process, we will follow the below step. Step 1. There is no regression testing in release number 1 because there is no modification happen in the release number 1, as the release number 1 is new itself. Step number 2. The concept of regression testing starts from release number 2 when the customer gives some new requirements. Step number 3. After getting the new requirement, they understand the needs before going to the impact analysis. Step number 4. After understanding the new requirements, we will perform one round of impact analysis to avoid the major risks, but here the question arises, who will do the impact analysis? Step number 5. The impact analysis is done by the customer based on their business knowledge, the developer based on their coding knowledge, and most importantly, it is done by the test engineer because they have the product knowledge. Note, if a single person does, he or she may not cover all the impact areas, so we include all person that we may cover a maximum impact area, and the impact analysis should be done at the early stage of the releases. Step number 6. Once we are done with the impact area, then the developer will prepare the impact area document, and the customer will also prepare the impact area document so that we can achieve the maximum coverage of the impact analysis. Step number 7. After completing the impact analysis, the developer, the customer, and the test engineer will send the report of the impact area document to the test lead, and in the meantime, the test engineer and the developer are busy working on the new test case. Step number 8. Once the test lead get the reports, he or she will consolidate the report and store in the test case requirement repository for the release number 1. Note, test case repository, here we will save all the test case of the releases. Step number 9. After that, the test lead will help up RTM and pick the necessary regression test case from the test case repository, and those files will be placed in the regression test suite. Regression test suite, here we will save all the impact area test document. Regression test cases, these are the test cases of the old release text document which need to be re-executed as we can see in the below image. After that, when the test engineer has done working on the new test cases, the test lead will assign the regression test case to the test engineer. And the last, when all the regression test cases and the new features are stable and pass, then check the impact area using the test case until it is durable for all feature plus the new feature, and then it will be handed over to the customer. Types of regression testing. The different types of regression testing are as follows. First, we have unit regression. Second, regional regression testing. Third is full or complete regression testing. Let's discuss it one by one. First, unit regression testing or URT. In this, we are going to test only the change unit, not the impact area, because it may affect the component of the same module. Example number 1. In the below application and in the first build, the developer develops the search button that accepts 1 to 15 characters. Then the test engineer tests the search button with the help of the test case design technique. Now the client does some modification in the requirement and also requests that the search button can accept 1 to 35 characters. The test engineer will test only the search button to verify that it takes 1 to 35 character and does not check any further feature of the first build. Therefore, we can say that by the testing only the change feature, it is called the unit regression testing. Second one is regional regression testing or RRT. In this, we are going to test the modification along with the impact area or regions. Here we are testing the impact area because if there are dependable modules, it will affect the other modules also. For example, as we can see that we have 4 different modules such as module A, B, C, and D, which are provided by the developers for the testing during the first build. Now, the test engineer will identify the bug in the module D. The report is sent to the developer and the development team fix those defects and send the second build. In the second build, the previous defects are fixed. Now, the test engineer understands that the bug fixing in the module D has impacted some feature in the module A and module C. Hence, the test engineer first tests the module D where the bug has been fixed and then check the impact area in module A and module C. Therefore, this testing is known as regional regression testing. While performing the regional regression testing, we may face the below problem. In the first build, the client sends some modification in the requirement and also want to add new features in the product. The needs are sent both to teams. Example, the development and testing team. After getting the requirements, the development team start doing the modification and it also develop the new feature based on the needs. Now, the test lead send mail to the client and ask them for that all the impacts area that will be affected after the necessary modification has been done. Therefore, the customer will get an idea which all features are needed to be tested again. He or she will send a mail to the development team to know which all areas in the application will be affected as a result of the changes and addition of the new features. And similarly, the customer sends an email to the testing team for a list of for the list of impact area. Hence, the test lead will collect the impact list from the client, development team, and the testing team as well. This impact list is sent to all the test engineer who look at the list and check if there's any feature who's modified, and if yes, then they will do regional regression testing. The impact areas and the modified area are all tested by the respective engineers. Every test engineer tests only their feature that could have been affected as a result of the modification. The problem with this above approach is that the test lead may not get the whole idea of the impact area because the development team and the client may not have so much time to revert his or her emails. The solution for this is to resolve the above problem. We will follow the below process. When a new build comes along with the latest features and the bug fixes, the testing team will arrange the meeting where they will talk about if their features are affecting because of the above modification. Therefore, they will do one round of impact analysis and generate the impact list. In this particular list, the test engineer tries to enclose the maximum probable impact areas, which also decreases the chance of getting the defects. When a new build comes, the testing team will also do the following procedure. They will do smoke testing to check the basic functionality of application. Then they will also test the new feature. After that, they will check the change feature. Once they are done with checking the change features, the test engineer will retest the bug fix, and then they will check the impact area by performing a regional regression testing. Now let's discuss the disadvantage of using unit and regional regression testing. Following are some of the drawbacks of unit testing and regional regression testing. We may miss some impact area. Also, it is possible that we may identify the wrong impact area. We can say that the major work we do on the regional regression testing will lead us to get more number of defects. But if we will perform the same dedication to work on the full regressing testing, we will get less number of defects. Therefore, we can determine here that the enhancement in the testing effort will not help us to get more defects. For the third, we will discuss full regression testing or FRT. During the second and the third release of the product, the client asks for adding 3 to 4 features, and also some defects need to be fixed from the previous release. Then, the testing team will do the impact analysis and identify the above modification, which lead us to test the entire product. Therefore, we can say that testing the modified features and also the remaining features is called the full regression testing. When we perform full regression testing, we do the following. When the modification is happening in the source file of the product, for example, JVM or Java Virtual Machine is the root file of the Java application, and if there is any change going to happen in the JVM, the entire Java program will be tested once or when we have to perform the n number of changes. The regional regression testing is ideal approach of regression testing, but the issue is we may miss a lot of defect while performing the regional regression testing. And we are going to solve the issue with the help of the following approach. When the application is given for the testing, the test engineer will test the first 10 to 14 cycle and will do the regional regression testing. Then, for the 15th cycle, we do the full regression testing. And again, for the next 10 to 15 cycle, we do regional regression testing. And for the 31st cycle, we do the full regression testing. And we will continue like this. But for the last 10 cycle of the release, we will perform only complete regression testing. Therefore, if we follow the above approach, we can get more defect. The drawback of doing regression testing manually repeatedly will be it will produce the productivity will decrease. It is difficult job to do. There is no consistency in test execution, and the test execution time is also increased. Hence, we will go for the automation to get over with these issues. When we have n numbers of the regression test cycle, we will go for the automation regression testing process. Automated regression testing process. Generally, we go for the automation whenever there are multiple releases or multiple regression cycle or there is the repetitive task. The automation regression testing process can be done in the following step. The process of testing and the application by using some tool is known as automation testing. Suppose if we take one example of a login module, then how we can perform the regression testing. Here, the login can be done in two ways, which are as follows. By manually, in this we will perform regression only one and twice. Automation, in this we will do the automation multiple times as we have to write the test script and do the execution. Step number 1, when the new release starts, we don't go for the automation because there is no concept of regression testing. And the regression test case, as we understood, step number 2, when the new release and the enhancements start, we have two teams, the manual team and the automation team. Step number 3, the manual team will go through the requirements and also identify the impact area and handed over the requirement test suite to the automation team. Step number 4, now the manual team start working on the new features and the automation team will start developing the test script and also start automating the test case, which means that the regression test case will be converted into test script. Step number 5, because the automation team start automating the test case, they will also analyze which all cases can be automated or not. Step number 6, based on the analysis, they will start the automation, example converting every regression test case into test script. Step number 7, during this process, they will take help of the regression cases because they don't have product knowledge as well as the tool and the application. Step number 8, once the test script is ready, they will start the execution of this script and on the new application. Since the test script is written with the help of the regression feature or the old feature, once the execution is completed, we get a different status like pass or fail. Step number 10, if the status is failed, which means it needs to be reconfirmed manually, and if the bug exists, then it will report to the concerned developer. When the developer fixes the bug needs to be retested along with the impact area by the manual test engineer, and also that script need to be re-executed by the automation test engineer. Last, the process goes on until all new feature and the regression feature will be passed. Benefits of doing regression testing by the automation testing. Accuracy. It's always exists because the task is done by the tool and the tool never get bored or tired. The test script can be reused across multiple releases. Batch execution. Batch execution is possible using the automation. All the written test script can be executed parallel or simultaneously. Even though the number of regression test cases increase, release per release, and we don't have to increase the automation resources since some regression cases are already automated from the previous releases. Time-saving process. It is a time-saving process because the execution is always faster than the manual method. How to select test case for regression testing. It was found from the industry inspection the several defects reported by the customer were due to the last-minute bug fixes, this creating side effects and hence selecting the test case for regression testing is an art, not an easy task. The regression test can be done by a test case which can be frequent defect, a test case which has a frequent defects, functionalities which are more visible to the users. Test cases verify the core feature of the product. Fourth, the integration test cases. Fifth, all complex test cases. Next, boundary value test cases. Next, a sample of successful test cases. And last, failure of test cases. Configuration management in the regression testing become imperative in agile environments, where a code is continuously modified. To ensure a valid regression test, we must follow the following steps. Changes are not allowed in the code during the regression testing phase. Also, a regression test case must be an unaffected developer change. Last, the database used for regression testing must be isolated. Changes are not allowed in the database. Difference between retesting and regression testing. Retesting testing means testing the functionality or bug again to ensure the code fix. If it not set, the defect need not to be reopened. If fixed, the defect close. Retesting is a type of testing which performed to check the test cases that were unsuccessful in the final execution are successfully passed after the defect referred. Regression testing means testing the software application when it's undergo a code change to ensure that the new code does not affect the other parts of the software. Regression testing is a type of testing executed to check whether a code has not changed in the existing functionality of the application. Difference between the retesting and the regression testing is shown in the image. Advantage of regression testing. Regression testing increases the product quality. It also ensures that any bugs or any bug fix or changes does not impact the existing functionality of the product. Automation tools can be used for regression testing. It makes sure the issues fix does not incur again. Disadvantage of the regression testing. There are several disadvantages of regression testing. Regression testing should be done for a small change in the code because Even a slight change in the code can create issues in the existing functionality. Also, even if it is cause automation is not used in the project for testing, it will be time consuming and tedious task to execute the task test again and again. If the software undergoes frequent change, regression testing costs also increase. In those cases, manual execution of test case increases test execution times as well as cost. In that case, automation testing is the best choice, for the duration of automation depends on the number of test cases that remain reusable for successive regression cycles. Following are the essential tools used for regression testing. Selenium. We have first Selenium. It is an open source tool used for automation testing of web application. Panoramic Studio is the second one. It allows all-in-one regression test automation for desktop, web, and mobile app with built-in Selenium WebDriver. Third, we have Quick Test Professional. It is an automated testing tool for regression and functional testing. Fourth, we have the Rational Functional Tester. It is a Java tool used to automate the test case of software applications. Last, also we have JUnit. We will discuss the JUnit on the next topic. In this topic, we will discuss JUnit, so let's get started. First, let's define what is JUnit. JUnit is a unit testing framework for Java programming language. JUnit has been important in the development of test-driven development and is one of the family unit of testing framework collectively known as XUnit that originated with JUnit. JUnit promotes the idea of first testing, then coding, which emphasizes on setting up the test data for a piece of code that can be tested first and then implemented. This approach is like test a little, code a little, test a little, code a little. It increases the productivity of the programmer and the stability of the program code, which in turn reduces the stress on the programmer and the time spent on debugging. So let's discuss the features of JUnit. JUnit is an open source framework which is used for writing and running tests. It provides annotation to identify the test methods. It also provides assertion for testing and expected results. JUnit also provides test runner for running tests. JUnit's tests allow you to write code faster, which increases quality. JUnit is elegantly simple. It is less complex and take less time. JUnit tests can be run automatically and they check their own result and provide immediate feedback. There's no need to manually come through a report of test results. JUnit also tests. JUnit tests can be organized into test suites containing test cases and even other test suites. JUnit shows test progress in a bar that is green if the test is running smoothly and it turns red when it's failed. Now let's discuss what is unit test case. A unit test case is a part of code which ensures that another part of code works as expected. To achieve the desired result quickly, a test framework is required. JUnit is a perfect unit test framework for Java programming language. A formal written unit test case is characterized by unknown inputs and an expected output, which work out before the test is executed. The known input should test a precondition and the expected output should test a postcondition. There must be at least 2 unit test cases for each requirement, one positive test and one negative test. If a requirement has sub-requirements and each sub-requirement must have at least 2 test cases as positive and negative. Next, JUnit is test framework. JUnit is a regression testing framework used by developers to implement unit testing in Java and accelerate programming speed and increase the quality of code. JUnit framework can be easily integrated with either of the following. Eclipse. Eclipse is a Java-based application and has require a Java runtime environment or Java Development Kit, also known as JRE or JDK, in order to run. Next, we have Apache Ant. Apache Ant is a software tool for automating software build processes. It is similar to Make build tool of Unix, but is implemented using the Java language and require the Java platform. Third, we have Maven. Maven is a build automation tool used primarily for Java projects. Maven can also be used to build and manage projects written in C#, Ruby, Scala, and other language. Features of JUnit Test Framework. JUnit Test Framework provide the following important features. We have the fixtures, test suites, test runner, JUnit classes. We will discuss it one by one. So let's begin. First, fixtures. Fixtures is a fixed state of a set of objects used as a baseline for running tests. The purpose of a text feature is to ensure that there is a well-known and fixed environmental in which tests are run so that the results are repeatable. It includes setup method, which run every test invocation, and teardown method, which run after every test method. Here is a sample code for here is a sample code using fixtures. Next, we have test suites. A test suite bundle a few unit test cases and run them together. In JUnit, both @runWith and @suite annotation are used to run the suite test. We can see the sample code that using test suites. Next, we have still continuation of test suites. A sample code using test suites. Third, we have the test runner. Test runner is used for executing the test cases. Here is an example that assumes the test class test JUnit already exists. Yan. Here we can see a sample of a code using test runner. Fourth, we have the JUnit classes. JUnit classes are important classes used in writing and testing JUnits. We have the assert. It contains a set of assert methods. Test case contain a test case that define the fixture to run multiple tests. Test result contains method to collect the result of executing a test case. Now let's discuss JUnit API. The most important package in JUnit is JUnit.framework, which contain all the core classes. Some of the important classes are as follows. We have the assert class. This class provides a set of assertion methods useful for writing tests. Only field assertions are recorded. We have the second one, the test case class. A test case defines the fixtures to run the multiple tests. We have the third one, test result class. A test result collects the result of executing a test case. It is an instance of collecting parameter pattern The test framework distinguishes between failures and errors. A failure is anticipated and checked for with assertion. Fourth, we have test suite. A test suite is a composite of a test. It's run a collection of test cases. We also have JUnit suite test. Test suite is a bundle is used to bundle a few unit test cases and run them together. In JUnit, both at run with and at suite annotations are used to run the suite test. Next, we have the ignore test. Sometimes it is so happen that our code is not completely ready while running a test case. As a result, the test case failed. The @ignore annotation helps this scenario. A test method annotated with @ignore will not be executed. If a test class is annotated with @ignore, then none of its test method will be executed. Then we have the JUnit test time. JUnit provides a handy option of timeout. If a test case takes more than the specified number of milliseconds, then JUnit will automatically mark it as failed. The timeout parameter is used along with @test timeout annotation. Next is exception test. JUnit provides an option of tracing the exception handling of code. You can test whether the code threw a desired exception or not. The expected parameter is used along with @testExpected annotation. And for the last part, JUnit extension. First, we have the Cactus. Cactus is a simple test framework for unit testing server-side Java codes. The intent of the Cactus is to lower the cost of writing tests for server-side code. It's used JUnit and extend it. Cactus implement an in-container strategy that execute the test code inside a container. We also have the JWebUnit. JWebUnit is a Java-based testing framework for web application. It wraps existing testing frameworks such as HTML Unit and Selenium with a unified, simple testing interface to test the correctness of your web applications. Third, we have the XML Unit. XML Unit provides a single JUnit extension class, XML test case, and a set of supporting classes that allow assertions to be made. Fourth, we have the mock object. In a unit test, mock object can stimulate the behavior of a complex, real non-mock object and are therefore useful for a real object is impractical or is impossible to incorporate into a unit test case. That's the end of my presentation. Thank you for listening and have a good day.